continue our discussion on surface area, today we're going to look at the surface areas of pyramids and cones. These are slightly different from prisms and cylinders, but only because pyramids and cones have only a single base. The base can be any polygon, and all of the other faces are the lateral faces. These are triangles which meet at the vertex. A pyramid is named by the shape of its base. So this pyramid at the top, because its base is a hexagon, is a hexagonal pyramid. The pyramid at the bottom, because its base is a square, is referred to as a square pyramid. In fact, this is the type of pyramid that the pyramids in Egypt are. They are all square pyramids. If the base is a regular polygon, then the whole figure is referred to as a regular pyramid. The height of the pyramid is the perpendicular distance from the vertex to the base. There's also another height called a slant height, which we illustrate with the script letter L, which is the height or the altitude of each lateral face. Now, if it's a regular pyramid, then the lateral faces are all isosceles triangles. Now, to help us find the surface area, we do the same thing as we did for cylinders and for prisms, in that we find the area of the base, and we find the lateral area, the area of the lateral surfaces, and then we add them all together. For the pyramids, the lateral surfaces are adding together each of the triangles, and as we know, the area of a triangle is 1/2 base times height. In this case, the base is the side of the actual base of the pyramid. The height is the slant height of the pyramid, so we get 1/2 times S, which is the side length, times L, and if we add them all together, we're taking this side length times the number of sides that there are, so we have basically the perimeter of the figure times 1/2 times the slant height, and that's where this formula for the lateral area of a pyramid comes from. And then to find the surface area, we simply add that to the area of the base. So if we look at an example, in this case, we want the surface area of the hexagonal pyramid, so the surface area is going to be lateral area plus the area of the base. The lateral area is going to be 1/2 times the perimeter of the base times the slant height plus, and the base, area of the base, it's a hexagon, it's regular hexagon, so we're going to use 1/2 times the apothem times the perimeter of that figure. Now, if we fill in this information, the perimeter of the base, each side is 6 inches. There's 6 of them, so we have 36, times the slant height, which is this height, so we have 9. We're going to add to that 1/2 times the apothem, which they already gave to us, so we don't have to figure it out, is 3 radical 3, times the perimeter, which again is 36. We simplify each of these figures, so 1/2 times 36 is 18, times 9 is 162, plus we do 1/2 times 36 is 18, times 3 we get 54, square root of 3. Put this into our calculator, and again, to make sure that the calculator knows what we're doing, we're going to do 54 times the square root of 3, find out what that number is, and then add to it 162. If we round to the nearest hundredth, we get 255.53. Our unit is inches, so our answer is in inches squared. For another example, this time we have a square pyramid, has base edges of 5 meters and a slant height of 3 meters. What is the surface area? Now again, I like pictures, so I'm going to draw this. Now keep in mind, pyramids can be slightly difficult to draw. It doesn't have to be perfect, so long as we kind of get the idea of a pyramid. The slant height is 3 meters. The base edge is 5 meters. See, my pyramid doesn't look really pretty, but that's okay. Surface area is the lateral area plus the area of the base. It looks like a 13, but that's supposed to be a B. Now, lateral area is going to be 1/2 times the perimeter of the base times the slant height, plus, in this case, the base is a square, so we're going to do the side squared, which is the same as base times height, but they're the same. So 1/2 times the perimeter. The base edge is 5. There are 4 of them, so the perimeter is 20, times a slant height of 3, plus 5 squared. 1/2 times 20 is 10, times 3 is 30, plus 5 squared is 25. 30 plus 25 is 55. Our unit is meters, so our answer is meters squared. Okay. Very easy, straightforward. Now we have another hexagonal pyramid, so again, same formula, surface area equals lateral area plus the area of the base. Lateral area is 1/2 times the perimeter of the base times the slant height. In this case we have a hexagon, so we're going to use the formula for a regular polygon. So we have 1/2 times the perimeter. Well, one side is 36 and there are 6 of them, so 6 times 36. I'm going to write that out because I don't know what that is in my head. And we need the slant height, but we don't have the slant height. Now the slant height, if we draw that in, is the hypotenuse of this right triangle. So we can use our Pythagorean theorem, a squared plus b squared equals c squared, to find that. We're looking for the hypotenuse, so we're looking for c. So we have 42 squared plus 18 radical 3 squared. Okay, 42 squared is 1,764. 18 radical 3, this would be 18 times the square root of 3 times the square root of 3. Now when I take the square root of 3 and multiply it times itself, I get 3. So we have 18 times 3, we get 972. And that is c squared. If I add these two together, I get 2,736. I check my calculator, I find that is not a perfect square, so we have to make a factor tree. So 2,736. 4 goes into it 684 times. 4 is 2 times 2. 684, 9 goes into that. It goes into it 76 times. 9, of course, is 3 times 3. Okay. 76, I know at least 2 is going to go into it. I check, I find that actually 4 goes into it. It goes into it 19 times. 4 is 2 times 2. So I have 1 pair of 2s, 2 pair of 2s, a pair of 3s. So I'm going to have 2 times 2 times 3 on the outside, so I get 12. On the inside is 19, and that is my C. So my slant height is 12 radical 19. I'm going to add to that 1/2 times the apothem. Now the apothem is this distance here, because if we draw in the triangle of interest, that's the height of that triangle of interest on our base. So we have 18 radical 3 times the perimeter, which is going to be the 6 times 36 again. Alright, lots of numbers. Calculator is really going to come in handy on this one. We do 1/2 times 6 times 36 times 12. We get 1,296 square root of 19 plus, and we add to that, we're going to do 1/2 times 18 times 6 times 36. We get 1,944 square root of 3. Now we put this into our calculator, round to the nearest hundredth. We get 9,016 and 24 hundredths. Our unit was feet, so our answer is in square feet. Okay. Now when we look at cones, cones are very similar to pyramids. It is simply a solid that has a circular base and a vertex that's not in the same plane as the base. Very important there. In a right cone, the height is from the vertex to the center of the base. The slant height is the distance from the vertex to a point on the edge of the base or on the edge of the circle. And unless otherwise stated, again, we're going to assume that they are right cones rather than oblique cones. Now, in order to find the area of cones, the lateral area is half the circumference of the base times the slant height. So if we think of half the circumference, circumference is 2 times pi times r, so half of that would just be pi times r, and that times the slant height, so we have pi r L. The surface area is the sum of the lateral area the area of the base, just like before. So when we look at an example, if I want to find the surface area equals lateral area plus the area of the base. Lateral area, remember, is half of the circumference times the slant height. Area of the base is going to be the area of the circle, which is pi r squared. So we have pi, in this case, times a radius of 15 times a slant height of 25. And then we have, for the area of the base, pi times the radius of 15 quantity squared. Now we go through on our calculator, and we find that 15 times 25 is 375 pi, plus 15 squared is 225 pi. Now this wants it in terms of pi, so we're going to leave the pi. So 375 plus 225, we get 600 pi. Our unit was centimeters, so our answer is centimeters squared. Okay. All right. One more example. Here we have the radius. The base of a cone is 16 meters. Now again, as you know, I'm a fan of pictures. All right, so here's my base, here's my radius. All right, again, doesn't have to be perfect so long as we get an idea. So we have a radius of 16 meters. Slant height is 28 meters. All right, here's my actual height. Not exactly perpendicular, but we get the idea. Surface area equals lateral area plus the area of the base. The lateral area, remember, is half the circumference times the slant height. So pi r times the slant height of L plus the base, which is pi r squared. So we have pi times a radius of 16 times a slant height of 28 plus pi times the radius of 16 quantity squared. Again, we're leaving this answer in terms of pi. So 16 times 28, we get 448. 16 squared is 256. So 448 plus 256, we get 704 pi. Our unit is meters, so our answer is in meters squared. Okay, very straightforward, very simple.